Hello everybody, my name is Gautam and I am going to be presenting Jianbo Shi today. Jianbo Shi is the researcher whose work forms the bedrock of how modern machines perceive motion and structure. Jianbo began his academic journey at Cornell University, where he earned his bachelor's in computer science and mathematics. However, his most transformative years were spent at UC Berkeley during the mid to late 90s. While at Berkeley, he worked under the guidance of Jitendra Malik, who many of you know is a titan in the field. At that time, computer vision was at a crossroads. Researchers were struggling to get computers to recognize objects in the real world, where lighting changes and backgrounds are cluttered. Jianbo wasn't just interested in the math, he was interested in human perception. He wanted to know, how does the human eye naturally group pixels together to see a thing rather than just a mess of colors? This curiosity led to two of the most cited papers in the history of computer vision. In 1994, Jianbo Shi and Carlo Tomasi published Good Features to Track. To understand why this was revolutionary, you have to understand the failure of the previous systems. Earlier trackers would drift. They might start by tracking a car, but after 3 frames, the tracker would slide onto the asphalt or a tree in the background. Shi and Tomasi asked a fundamental question: what makes a pixel trackable? They realized that for an algorithm to follow a point through rotation, scaling, and lighting changes, the point must have high texture in multiple directions. They developed a mathematical criterion, now famously known as the Shi-Tomasi corner detector, that looks at the eigenvalues of the local intensity gradient. This isn't just academic, it's the reason why a drone can follow an athlete or why Hawkeye can lock onto a cricket ball against a crowded stadium background. It was the first time we had a mathematical guarantee of which points in an image were trustworthy for motion estimation. A few years later, in 2000, Shi and Malik published their work on normalized cuts. This moved the field from tracking single points to understanding entire shapes. Before this, image segmentation was bottom-up. Computers tried to group pixels that looked similar, but this often failed when an object had shadows or different colors on it. Shi's breakthrough was to treat the entire image as a graph, where every pixel is a node connected to its neighbors. He used spectral clustering, a concept from graph theory, to find the global optimum for where one object ends and another begins. Instead of looking at tiny windows of pixels, the normalized cut looks at the entire image at once. It effectively asks, what is the most efficient way to cut this image into 2 meaningful pieces? This allowed computers to segment complex scenes, like a player on a field or a car on a road, with the level of accuracy that mimicked human grouping principles. Today, Jianbo Shi is a professor at the University of Pennsylvania, where he leads the GRASP lab. His current work focuses on first-person or egocentric vision, teaching AI to see the world from a human perspective, like through a pair of AR glasses. The legacy of his early work is hard to overstate. Every time you use portrait mode on your phone to blur a background or see a sports broadcast highlighting a moving player in real time, you are seeing Jianbo Shi's algorithm in action. He took the abstract world of graph theory and eigenvalues and turned them into the eyes of modern technology. His career serves as a perfect example of how deep mathematical intuition can solve the most practical problems in human experience. This brings me to the end of my presentation. Thank you so much for your time and attention.